Bohr effect. Increase in H+, lowering of pH, decreases affinity of hemoglobin for oxygen. Increased CO2 in the blood or increased lactic acid will lower the pH. Increased release of oxygen to respiring rapidly tissues or muscle-releasing lactic acid. Why do H+ ions affect oxygen binding? pH affects the protonation states of amino acid residues. When H+ is high, additional residues are protonated, particularly histidine residues. Additional positively charged residues can form new salt bridges. These stabilize the T state and decrease affinity for oxygen. Regulation by bisphosphoglycerate, BPG. Bisphosphoglycerate, BPG, is found at high concentrations in erythrocytes. Bisphosphoglycerate levels increase at high altitude and in hypoxia, poor oxygenation of peripheral tissues. Bisphosphoglycerate decreases affinity of hemoglobin for oxygen, so causing more oxygen release in these conditions. Bisphosphoglycerate binds in the space between the beta subunits, in the T state only. Negative charges on the bisphosphoglycerate interact with positive amino acid residues lining the space. H+, CO2 and bisphosphoglycerate interact at different sites, therefore their effects are additive. Fetal hemoglobin binds oxygen more strongly than adult hemoglobin. Fetal hemoglobin, A2 gamma 2, adult hemoglobin, A2 beta 2. HbF binds BPG less effectively, so has higher affinity for oxygen. It allows efficient transfer of oxygen across the placenta. Hemoglobinopathies. A range of inherited disorders affecting hemoglobin synthesis, structure and function. Sickle cell anemia happens in 8 to 10,000 in the UK, people of African Mediterranean origin. Beta thalassemia happens to 600 in the UK, for people of Mediterranean origin. Mutations may affect the amount of hemoglobin synthesized, the structure, e.g. subunit interfaces, the stability of hemoglobin, leading to hemolytic anemia, and the affinity for oxygen. Affinity for regulators, e.g. BPG. Critical amino acid residues. Sequences of hemoglobin from over 60 different species is known. Only 9 residues are invariant. F8 has the amino acid His, and its role is proximal His. E7, amino acid His, distal His is the role. CD1, amino acid Phi, its role is heme contact, etc. Why don't all mutations cause disease? Mutations in critical residues will affect function. Conservative or non-conservative mutations. A conservative substitution maintains hydrophobic interior of the molecule. The interior of hemoglobin is often sees a change of one non-polar residue to another, e.g. alanine to ILE. Non-conservative substitution, e.g. leucine to lysine, will have a major effect on protein structure and function. Collagen is a structural protein. Family of fibrous proteins, forms insoluble fibers, high tensile strength, most abundant protein in mammals, a quarter of the total weight. It's a major fibrous element of skin, bone, tendon, cartilage, blood vessels, and teeth. It's present in most organs. It holds cells together in discrete units, called a basement membrane. It also has a direct role in developing the tissue. Collagen is a structural protein. It is in a family of fibrous proteins. It forms insoluble fibers with high tensile strength. It's the most abundant protein in mammals, at a quarter of total weight. It's major fibrous element of skin, bone, tendon, cartilage, blood vessels, and teeth. It's present in most organs. It holds cells together in discrete units called basement membranes. It also has a directive role in developing tissue. There are different types of collagen due to different polypeptide chains in tropocollagen. At least 12 different types of collagen. Some sources list as many as 28. Types 1, 2, and 3 are the most common. They form long fibrils, fibril-forming collagens. Types 4 and 7 form two-dimensional matrix, important in the basal lamina, network-forming collagens. Other collagen types are mainly associated with major forms and may be involved in cross-linking, e.g. types 5, 9, and 12, fibril association collagens. Biosynthesis of collagen. Polypeptide synthesis, most translational modifications, and procollagen triple helical cable. Secretion, removal of extension peptides, tropocollagen, aggregation into microfibril, and cross-linking to form collagen fiber.